So here we are again to deal with generalization, and to do that I will show you our notebook where we have a section called generalization. As we pointed in our paper, generalization is based on the variation of congestion control, as we can see here, and the number of flows. So, okay, I will show you the process for neuronal and 20 flows. So you have to go to our virtual machine. We have to access this file here. Okay, you are familiar with. So you have to change these parameters here. Okay, we have to put here TCP renal, as we have here. Remember, okay, so we have to configure our parameters to that. Simulation time, as we pointed in our article, is 30 minutes, so the time is 1,800 seconds. Okay, flows, we want 20 flows. Start, flows interval the same, bottleneck height the same, halter period the same, max runtime for new X the same. Training data, no, we want generalization data, so you have to change these parameters here. Training data, generalization data, intelligent congestion control, we have no one. And neural architecture, as we have no intelligent CC, we have no neural network, we don't care about the network architecture, and we work with no bear at this phase. So let's save this file here. Let's execute this command here. Okay. So here's running the simulation. Let's go to the output folder and let's observe that we have here a folder indicating that we have a simulation to generalization data. Inside that we have these files here. As you can see, you have TCP neuronal 20 flows, 100 Mbps is the data here. So at the end of the simulation, we will copy these files to our drive and use them its data as an input of our neural networks to test its classifiers. So the simulation ended here. So let's go to our output folder. It's this one here. Okay, output folder. This is the folder of the simulation of the last simulation. Let's select here. Let's copy. Let's go to our Google Drive. the easy app round rack round 2. We have to create a new folder for new Reno 20 flows underscore new here corresponding to this simulation. So let's post it. Let's post the file here. File is. So here you have the files uploaded. Let's go back to our notebook. Let's point these files. Okay. And let's rename this file here. This named as I will explain to you. Let's rename to make things simple. So let's update here. Okay, the file was renamed. So let's execute this cell here to input the data in NLP XNRTT architecture. Let's go. So it's executing here. Some output we have here. Okay. Okay. It's running, it's processing. So here we have, so here we have a balancing process. Okay, and this is the confusion matrix present by this model here. It's a very good confusion matrix. Let's go to the next one. That's MLP and RTT. Let's go there. Let's go to this one here. This one here, we're not so good, but to have a good confusion matrix, not so good as this one, but a great result too. Let's go to the next one. This one is the MLPR using EC and RTT. And let's go to the next one. This with SAM and RTT using MLP. So let's go to the results. Very good results, great results. Okay, so it's taking the data, input this data, the vectors that come from the data processing, and we have these that produce the input vectors that input the classifiers extract from these models here. So let's go to the LSTM, the first one, LSTM, AXN and RTT. Let's go there. Okay, not so good, but a good result too. Let's go to the next one with the LSTM with EC and RTT, using EC and RTT. Okay, good results, but not so good as the previous one. Let's go to this one here with sand and RTT. Let's go. Okay, here. Okay. Let's go to the CNN models with the 3 features first. Let's wait. Good results with F and RTT. Let's see here. Great results. Amazing results. Let's go to sand and RTT using CNN. Okay, great results too. We have great results. So as you can see here, the next one is the cubic with 20 throws. So now we have to go to our simulation environment. So you have to go to the config file. Here we have to put cubic, and the others parameters is already okay. Execute the simulation, copy the data, paste in drive, go to our notebook, point to the right directory where we paste the data, and execute. So we are going to execute the classification for each one of the surviving models from training phase. So I will execute the simulations behind the scenes, and I will be back in the next video executing the models, the classifiers, extractor models, and exhibit their results based on the confusion matrix. So see you in the next video.